Okay, we're on our third video for this section, and that's going to finish it up. So on this we are looking at a function that is a parabola. So the parent function, or the common function, would be f of x equals x squared. So that's what we'll use in order to figure out the shifts once we get that on the graph. Once again, we're just using -1, 0, and 1. That makes it easy. When I square each one, I get either 0 or +1. So when we put this on the graph, we have to remember the shape, right? The shape of this is a parabola. And so we're going to do our dotted line. We certainly do not want this to look like a V, so you want to be careful there so you don't end up with a V when you are graphing. Because remember, when it looks like a V, that's absolute value. Well, trying to be more accurate here, even though I don't have those points graphed. Okay, so that's our common graph, our common parabola. It's strange how that one's going. Try to make it a little bit better. So now we have to talk about the shifts for our g function, and I may have repeated something. I got interrupted and had to pause there, so if it sounds weird, that's why. So within the parentheses we have a +2, so that means that it's going to shift left 2, right? That's what's going to happen with that. And then the +4 means it's up 4. Now, it may be confusing sometimes when you're looking at this. I'm going to scoot that 2 over a little bit. Why is it a different sign for what's inside the parentheses versus what's outside? It just has to do with the fact that it is written in this form in parentheses. X plus 2 is actually something completely different if you multiplied it all out, and that would go back to, you know, how it would factor into that form and some things that you don't really have to be worried about at this point. Just know, hey, I have to use the opposite sign right there, but I use the same sign with what's outside the parenthesis. Okay, so we're shifting left 2 and up 4. So with each of our points, right, left 2, up 4. So I'm starting over here on the right. 1, 2, 1, 2, 3, 4. And our vertex, right, that the lowest or highest point on the graph for a parabola is called the vertex. So I'm going to shift left 2, 1, 2, 1, 2, 3, 4. Oh, I maybe want to take that off so it's not as high up there. I can make this a shorter graph here by just taking off a couple of my dashes and say, okay, this is my little parabola down here. Okay, then for, let's see, where am I? Okay, this point, the one on the left, left 2, up 1, 2, 3, 4. And then we draw the parabola. And that's it. And we have our graph. Okay. Now, let's see if I put a little more, my arrow's a little off here. Okay. Oh well, it's never going to really look perfect, is it? Next graph. So we're graphing a square root function, and notice it is a reflection. So when we set up our common graph, we want to set it up with a reflection to begin with. So we have f of x equals the negative square root of x, right? Or the opposite of the square root of x. We're going to use 0, 1, and 4. You could put a 9 on there too, and that would be okay, but we'll just use these this time. And so when I take the square root of 0, it's still 0. Square root of 1 is 1, and it's negative. The square root of 4 is 2, and now it would be a negative. Okay, so let's put this on our graph at 0, 0. Remember, this is a reflection. So it needs to be below the x-axis, right? Because it would be reflecting across the x-axis. The original would have been up here, right? Like this, before the reflection. And then at 4, -2, we'll make this our dashed graph. I can't seem to dash. And there we go. Now let's talk about our transformation. Where is this thing going on the graph? And so what happens here is we have a shift. So inside is -1. That's going to be a shift right by 1 and then up 3. Looks like I did a lot more ups than downs. I should have made another negative in there. Okay, so shift right 1, up 3. For each of our points, right 1, up 3, 1, 2, 3. Right 1, 1, 2, 3 up. Right 1, 1, 2, 3. And that's our new graph. Remember, when you make the square root function, you have a starting point and you want to make sure that you're not drawing past that starting point with an arrow or anything, right? You just have to go, in this case, to the right. Okay, and then we have one more. Now, this one's kind of silly, but it is, because it would be easy to graph this without the parentheses. This is just a linear equation. It is a line, but it was in the homework, so I decided that we would do one of these. So let's say my function is g of x equals, let me look back at this. That needed to be a g of x because we already had an f function. I'm going to fix that. Okay, g of x equals, on this one, it would just be x, right? Because it's a line. It's simply a line. So if we use -1, 0, and 1, remember that's y equals x also. So whatever x is, y is the same thing. And so it makes a simple line, right? I think I'll put a little dash in there. No, that didn't really work out that well. That didn't either. Okay, it'll do. Yeah, we'll leave it. Now, let's talk about the transformation. Where are we shifting this? Oh, and see, I said domain and range and forgot to write that. We will go back and do domain and range. Okay. So on this one, it's going to shift right 1 and upward 4. Okay, so right 1, up 4, 1, 2, 3, 4. Right 1 up, 1, 2, 3, 4. And then right and 1, 2, 3, 4 up. And then we draw our line. And we've got it. Okay, so let's go back to that domain and range thing that I seem to have forgotten. Domain. Well, when it's a line, there are no restrictions, right? So if we don't have any restrictions on this, then we know that it is going to be from -infinity to +infinity, right? Basically all real numbers. So you can see this thing keeps going left and right. It continues on and on. And with the range, same thing. There are no restrictions. So -infinity to +infinity. Okay. We're going to go back a couple of slides, which is fine. I just forgot, even though I said that on that other one. So domain. And now this one does have some restrictions, right? Because it can't start in certain places due to negative numbers, right? We don't want a negative under the radical. But notice on the x's, this one starts at 1, right? 1, 2, 3, 1, 3. This ordered pair is 1, 3. And that actually helps you write your domain and range, okay? Because what happens is my starting point is at 1. So my domain will be from 1 to infinity, right? Because we're going to the right. We're going toward the positive numbers. And my range it's going to keep going down, right? It's never going to go above 3, if that makes sense. So it's from negative infinity to 3, and the 3 is included. So my stopping place at the top is 3, if that makes sense, because that's where my ordered pair is. That actually helps me with this graph. And I can't go any further to the left, right? Because that's not going to work out. If I put a 0 in right here, that would make the square root of -1, which is not a real number, therefore it can't be there. So 1 to infinity for domain, negative infinity to 3 for the range. And I think we had one more. We had 2 more. Okay, here we go. And so domain and range on this one, remember, we're only looking at the actual g function for this domain and range. So my domain starts, well, it doesn't have a starting place. What happens here, if you think about this, it just keeps going, right? So it gets wider and wider and wider and wider. And so that means that there are no restrictions on my my domain. And that means the x coordinates, right? Negative infinity to positive infinity. But notice on the range, right? Well, there's nothing happening below this parabola, right? If it's just starting at this ordered pair, which was 1, 2, -2, 1, 2, 3, 4. So at -2, 4. And so this never goes below the 4. And that means it's 4 to infinity. I'm thinking y coordinates, right? This would be my y coordinates. Okay, one more here. The one I underlined to try to remember. Okay, so notice on this one, same thing with the parabola. There aren't any restrictions on our x coordinates. So it's from negative infinity to infinity. And then on the range, if you look at this ordered pair, we're at -1, 1. It never goes above the 1. So, and you always write these from least to greatest, so that's why we have to start with the negative infinity. Negative infinity to 1, right? And the 1 is included in that. So it never rises above that. That's why we have to stop at the 1. And then that is all for this lesson. And it's okay if we had to go back and pick up domain and range. All right, that's it.